right, guys. So let's see. Anybody have any ideas for number 6? All right. Maria bought 7 boxes. A week later, half of all the boxes were destroyed in a fire. There are now only 22 boxes left. How many boxes did she start with? All right, so let me just see that she had X amount of boxes to start with. Then she had a certain amount of boxes, but then Maria bought 7 boxes. So the boxes that she have there, she went and she buys 7 more. But then half of all of the boxes were destroyed in a fire. So this is all of the boxes, but half of them were destroyed in a fire. So because half of the boxes were destroyed in a fire, she only have half left. And the half that she has left is 22. She has 22 boxes left. Right? It's really about the language of this question. The language of this question kind of messed up, right? Because it kind of given the information in a how kind of order. Maria bought 7 boxes. Okay. A week later, a week later is something that will mess with your head. But that week later really had nothing to do with nothing, right? Half of all the boxes were destroyed in a fire. Right? She bought 7 boxes. Half of all were destroyed in a fire. Now there are only 22 boxes left. Right? So, how many boxes did she have to begin with? So, what I was saying is, what do you want to find? You want to find how many boxes she had to start with, right? So to start with, she had X amount of boxes. Yeah. And now we saw that Maria bought 7 boxes. So she had X amount of boxes to start with, and then she bought 7 more boxes. Then half of all, so this is all the boxes she had, right? All of the boxes she had, which is the amount of boxes that she started with plus the 7 that she bought. Half of all were destroyed in a fire, which means now she only have half the amount left. So that is why I divide by 2. Half of all. So all is X plus 7. That's how many boxes she had in all. Half of them were destroyed, so you divide it by 2. And when half of them were destroyed, the half that she has left, which is this, is 22. She had 22 boxes left. But before Sarah busts the tape, let me see if anybody else could give me number 3. Once you know how to do number 3, then you're going to know how to do number 4. Right? So let me check 3 and 4 now. The sum of 3 consecutive numbers is 72. So that means that I have a number here, and sum is to add. I have a next number here and a next number here, and that is 72. What are the smallest of the numbers? And what does consecutive mean? Because if you say 9, then 9 consecutive means numbers that come right after each other. So the sum, and this is the thing, the problem with math is English. The biggest problem with maths is English, right? So the sum of 3 consecutive numbers, look at what the English saying. Consecutive means numbers that come one after the other. So if the smallest number is 9, well then the next number would have to be 10, and the next number would have to be 11. And I'm pretty sure that doesn't equal 72. So the sum of 3 consecutive numbers equals 72. What is the smallest of those numbers? You know, you have like 9, 10, 11, you had 23, 24, 25. We'll take a look at it, right? If the smallest number is where you want to find, well then that'll be x plus then this number is the number after x. So this will be x plus 1, and plus this number is the number after x plus 1. Alright, so that'll be x plus 1 plus 1, which is x plus 2. Yeah. So now we have an equation x plus 1 plus x plus 2 equals 72. I see you understand how I arrived at that?
Only half is what I have.
You got it, Samira?
Oh, yes I did.
Yes, I thought you would have, you know. I thought you would have, yes? So, and then we can see here 1, 2, 3. 3x, alright, plus 1, 2 and 1 is 3, so plus 3 is equal to 72. And let's see if we get what Zara got, right? So 3x is equal to 72 minus 3, which is 72 minus 3 is 69. And x will be 69 divided by 3, which is 23.
But wait now, sir. What's sir? So I get 24 for our 3 now. I don't see what wrong.
You're way wrong.
Yes, sir.
You was trying as Zara approach and divide it by 3.
Yeah, and I get 24.
Yeah, but you had to test it. Right? If you get 24, then you had to test 24, 25, and 26. Right?
Yeah,
and if you do 24, 25, and 26, you might get 73 or 74. So that's what went on with Zara. She probably tried 24, 25, 26 and be like, alright. And then she tried 23, 20, you know? So she went trial and error. And she kind of figured it out. Yes.
You know the answer will be 3.
For number 4, I want the equation. The sum of 3 consecutive even numbers, So consecutive even numbers could be 2 plus 4 plus 6. Those are consecutive even numbers. Or you can have 14 plus 16 plus 18. Those are consecutive even numbers.
So I have equation.
So, yes, Sarah. Just now, let me hear Isaiah first. Isaiah, let me hear you. If x is the first even number, what will the second even number be?
Say, just already good.
Huh?
X plus 2.
So the second even number will be the first even number plus 2. Alright? And Asiya, I hope you're taking a look at this. What will the third even number be?
X plus 4.
X plus 4. Alright? And yes, and that will equal to 48. It's kind of a fresh way of thinking. And trust me, I am giving you guys harder ones than you will get there. Right? You will get, most of the time, you will get questions like number 1 or number 2 if you are given a worded question in exam. Number 1, number 2, number 5, those are the questions that you will kind of get. Right? If you're getting a worded question. These are some worded problems here. You have the consecutive ones here, but just try a couple of consecutive ones. Let me see. Let me just do 8 and 9. Let's just do 8 and 9 and then we'll move on to fractions. And this boils down to math as a language, because you know you have, remember when we were talking about it in the first class, we talked about nouns and we talked about verbs and how the nouns in maths are numbers. So 2 or a quarter or root of 3 or negative pi. Nouns in maths are numbers. Those are the things in maths. And the verbs in maths are doing. Right? So divide, multiply, right? But then you have adjectives. I spell adjective wrong. And an adjective, an example of an adjective might be equal, an equal sign. To say that this is equal to that. This is describing these two things. It is comparing these two things, right? You also have things like less than, greater than. All of these things could be seen as adjectives, right? So to say X is equal to Y, you could pretty much say X is Y. So when it comes to language, when you see the word is, think about that as the equal sign. That is a little hint for number 8. That is your hint for number 8. When I finish number 8 and number 9, just type done it in the chat, please. Remember, the quicker you do it is the quicker we go home. X equals 11 over 12. That is an answer. I don't want an answer. I want an equation. How you get that?
Well, I put 14 minus 8x equals 3 plus 4x.
Again, Isaiah, you are close. You're close. Anybody else?
3 points up. 8x minus 14
Yes.
is equal to 4x plus 3.
See the mistake you make, Isaiah?
Wrong spot.
Right, so it's 14 less than 8 times a number. So first of all, the number, right? What is the number, right? So let me see this. And Asiya, I'm explaining it now, so I hope you're just paying attention to this, right? And that doesn't go for Asiya, that goes for everybody. Yeah. Somebody left a message. Done it, please. All right. Where is, oh crap, come on. Right, yeah. So, what is the number? Well, the number is X. That is what the number is. 8 times a number is 8 times X. Yeah? 14 less than 8 times a number is 14 less than 8X. So that means that the 8X minus 14 is, so is equal, right? Is an adjective. It's saying that these two things are the same, right? Is 3 more. 3 more is when you're adding 3 than 4 times a number. 4 times the same number. And so we get that. And so now we can actually solve this, and I will solve this one. And I'm real sorry that this thing is lagging so much today. Alright. So I will solve this one. 8x minus 14 is equal to 4x plus 3. What I could do is I could bring all of my x's on one side. So I'll throw the 4x on this side, and I'll throw the negative 14 on this side. So what will I get? On this side I will have 8x, and this 4x is a plus 4x on this side, right? So when I throw it across on this side, it will become a minus 4x here. And it's a minus 14 on this side. So when I throw the 14 on this side, I'll have 3 plus 14. So now I will have 8 minus 4 is 4x is equal to 14, 15, 16, 17. 14 plus 3 is 17. Wow. We're getting a fraction, right? What is the number? X, the number is actually 17 on 4. And you can leave it so, because I don't think that could be 17 on 4, yeah. Yeah, that could just change to 4 1/4. But it can't really reduce or simplify. So you can leave it as this. So 3 consecutive integers. Alright, 3 consecutive integers. So if the first one is x, they'll be consecutive. So the second one, the sum. So because they say the word sum, I'm adding them. The second one will be x plus 1. And the third one will be x plus 2. So these are your consecutive integers. will be equal to 108. And so x plus x plus x, that is 3x plus 3 is equal to 108. I added the 1 and the 2. Right? And so now 3x is equal to 108 minus 3 is 105. And x will be 105 divided by 3, which is
35.
Thank you very much. Alright, and you know what? Sarah and Sabira, I'll choose characters. Sabira and Sarah.
So now go to Yoshi.
Alright, so Sarah going with Yoshi. Remember your character, please. And Sabira?
I don't know if it's characters. Is that Princess?
Well, somebody already chose Princess Peach here, but it does have this Princess Toad. I don't know what was this one name.
Toadette.
Zara, who's this girl name here? Toadette.
Toadette.
Yes, that is Toadette. Yes, I remember now. Yes, it is Toadette. By the way, the Semicircle Academy is in discussions with Nintendo right now. Email discussions talking about this Mario Math thing and actually putting it online and such. So hopefully, just now Semicircle and Nintendo will be working together with some Mario stuff. That'll be great. But that might still take like a year or to really come to fruition, right? Alright, so we have some players on the board there. Then we go to fractions now. So we're going to be talking about fractions today. And we probably wouldn't go to 8, but as I say, it depends on how quick you guys answer, right? So let's get it going with fractions. And the first thing we're going to talk about here is adding and subtracting fractions that have the same denominator. By the way, you all see in the whiteboard, right?
Yes, sir.
All right. So adding that have the same denominator. So imagine an example would be 1 over 5 plus 3 over 5. And you know when fractions have the same denominator, you can keep the denominator and just add the numerators, right? Or subtract, depending, right? So 1 plus 3 is 4 over 5, right? So this is what that looks like in algebra. You can see here that I have a plus or minus sign, and that is what that sign means. It means that this method works for plus or minus. So adding or subtracting. And you can see that I have A over C plus or minus B over C. So you could see that both of them are over the same denominator C. And so we just keep the denominator C and we add or subtract the numerators A, add or subtract B. Right? And that's pretty much it. However, this is a very useful thing when working the other way around. Right? So we can often use this method to split up fractions, and you have seen me done this. Whenever you have, if you have A plus B over one denominator, that is C. Right? A plus B over one denominator is C. Well then, we could split that up to be A over C plus B over C. So it's just really this going in the other way. Alright. Well, guess what? I have some fractions here that are over the same denominator, and I would like you to split these things up. So can you split these things up, please? I'll give you guys just a couple of minutes. Problem. Alright, so for the Mario Maths board, could I have the answer for number 1?
X over X plus 1 over X.
Yeah,
which
good.
X over
Yes, right. So this will split up. You could give me the final answer.
So that would be
Because it could simplify more than that. So this could.
X plus 1 over X.
Careful. Sarah, final answer. You said the correct thing just now, but it needed to go one step further. So this here is x, right, over the same denominator x. I have the plus sign, and then I have the 1 that is over the same denominator x. Yeah, and you can see here that this x could now cancel with this x, and that'll give us 1 plus 1 over x. Number 2, somebody different from Sarah. Anybody?
1 minus 2.
1 minus 2 over x. So let's see. We can see that we have this 2x over this denominator. So that is 2x over 2x. Then we have the minus sign. And then we have 4 over 2x. So we can see here that this 2x and this 2x will cancel to give me 1. I have the minus sign, and then I have 2 into 2, 1, 2 into 4, 2. So this will be 2 over x. Sabira, is that what you said?
Yes, sir.
Alright, just making sure. I thought I heard 2x there, right? So this is 1 minus 2 over x.
5x plus 1 over 6x squared plus 3x.
5x plus 1 over 6x squared plus 3x. That is not it, but I really applaud your try. You do something wrong with this numerator here. Remember, this is the distributive law. Now this 3x is being multiplied by this. We didn't talk about multiplication yet.
So I wasn't sure if it was being multiplied by because I see the plus sign on the denominator.
Yeah.
So I did multiply.
Right. But this goes to show you that even though this seems like two numbers, because you know addition separates numbers, right? So this does seem like two numbers, but this entire expression is being divided by this. So you could take this as being one denominator, right? So you could think about this, and I saw that you left it as one denominator, so that was very good, right? But you had to expand this, so we still have the one denominator there, right? 6x squared. Oh gosh, stop lagging though. This thing lagging. Plus 3x, and we have 3x times 2. 3 2's are 6x squared, and then 3x times 1 will be plus 3x. And look at that, we have 6x squared plus 3x over 6x squared plus 3x. So that means that, yeah, this number is the same as this number. The answer here is 1. So do you understand that the 2x minus 4 are over the same denominator, right?
Yes.
So do you understand that I could split it up? So I have this 2x over that denominator. I have the minus sign, and I have this 4 over the same denominator. You understand that?
Yeah.
You understand that 2x could go into 2x, and that'll give you 1?
Yes. I didn't get the one before. Don't think I can answer properly.
Right. You didn't
Wait,
get...
no, I had guessed. I don't know what I did, but I get number 3 correct, but for number 2, I get x take away 2 over x.
X take away... Oh, so what you did was you crossed off this and this, and you put x.
Yes.
So that was just a careless mistake. You meant to put 1, but you put
Yeah.
x. Yeah? But the x is cancelled too.
Yeah.
Yes, right? And then this here, this 2 will cancel with this 4 to give you 2, right?
Yeah.
So you'll have the minus, you'll have the 2 on top, and you'll only have x remaining underneath, because that 2 cancels to give you 1, right?
Yeah.
Understand it now?
Yeah.
And-
It's just the one I had the x.
Yes. Anybody else have anything they want me to explain? So we're going to talk about multiplying fractions now, which is one of the most important things, and it's slightly a bit different, right? So you'll notice I have two fractions here, a over b multiplied by c over d. Right? All you do when you're multiplying fractions is you multiply your numerators. So a times c is ac, and then you multiply your denominators. B times d is bd. That is it. That is all. That is everything. But please remember, multiplication is commutative. So just like how you have a times c, the numerator could also be written as c times a. And this commutativity is actually a very important and useful thing, and we will see why just now. Just now we'll see why, right? You can see that I flipped the b and the d here, but you notice that they are the same thing. Now, just like the addition one, we could do this in the opposite direction. If we were given, and look at this one very carefully, yeah? I'll give you guys time to write after, but pay attention now, right? You can see that we have the answer here, AC over BD, yeah? We could split this up in so many different ways. Look at this first way. I could split this up to be AC over 1 multiplied by 1 over BD. You all agree with this first one here?
Yes, sir.
Because if you look at the multiplication of fractions, AC times 1 will give me AC, and 1 times BD will give me BD. So with multiplication, I could split things up all kind of ways as long as I get back this same answer. Right? So look at the second way, where I could just say A over BD is multiplied by C over 1. A over BD multiplied by C over 1. Is this the same as this original answer? Yes, it is. Because look at how we multiply fractions. You multiply numerators, A times C will give us AC. And you multiply your denominators, BD times 1 is BD. Right? So you're seeing the different ways that I could split these things up. And this is not even all the ways. I'd have more ways that you could probably find to split it up. Then I have this way, A over B times C over D, which is what we had originally. Right? So you need to be able to look at the answer and be able to split it up into its fractions. A times C is AC, and B times D is BD. And guess what? I have this next way here that I split it up, because multiplication is commutative, right? So A times C is AC, and D times B is dB, but multiplication is commutative, so dB is the same as BD. Yeah, am I talking too much A, B, C, D, B, D, B, blee, blee, and all of them kind of thing? Anybody have any questions? Alright, so guess what? We're still talking about it, but the commutative law is the reason why we can cross cancel. What is cross canceling? Cross canceling is if I have 2 over 3 multiplied by 7 over 4, right? I could cancel this 1 here, this 2 here, 2 into 2, 1, and 2 into 4 is 2. I could cancel that, but why? Why is it that when I am multiplying, I could cancel the numerator from one fraction with the denominator from the next fraction? How is that possible? Well, the commutative law is the reason why that is possible. Because remember, 2 over 3 multiplied by 7 over 4 is equal to, and I'm just doing it on the side here, right? That is equal to 2 times 7 over 3 times 4, right? And remember, multiplication is commutative, so I could switch around. I could say 2 times 7 all over and switch around this 4 times 3. Multiplication is commutative. 3 times 4 is the same as 4 times 3. And then I could split it back up to get 2 over 4 times 7 over 3. So you see how the 2 cancelling with the 4 now. Yeah. So instead of going through all of this, this is the reason why cross cancelling works. Because of the commutative law. If I have A over B times C over A, why is it that this A could cancel with this A to give me the answer C over B? Why? A into A1, A into A1. Right? Why is that? Well, because, all right, look at this here. A times C is A times C over B times A is B times A. And because multiplication is commutative, I could switch. So I switch this one. I switch the numerator in this case. In this case, I switch the denominator, which is fine. Multiplication is commutative. So now I switch it. A times C is the same thing as C times A. It's commutative. And so now I could split it back up. So you get C over B times A over A. And that is why the A's could cancel. Let me see earlier.
Just a half X.
That is true, and you will roll the dice for that. Yes, a half times X is a half X, but that is not the answer that I wanted. But it is correct, so you will get to roll the dice. But what else? It could simplify more than that. Remember, what we do in here is multiplying fractions. So X could be seen as X over 1. Yeah, and so you could multiply your numerators. 1 times X is X, and then you have 2 times 1 is 2. And this is the reason why I gave you guys this question. Remember, I just keep putting this in all your head. A half X is the same as X over 2. Alright, anybody want to volunteer for number 2?
Me, sir.
Alright, so Isaiah, if it is that you get this question wrong, if you get this question correct, Zara has to move back 2 spaces. Right? So what did you get for this one?
12.
Huh? 12. Let's just see. Well, I could see here that this A could cancel with this A. Right? Remember, 4A is a multiplier, so 4A, you can see that as one number. So you're canceling the factor of A with this A. Right? And you can cancel this B with this B. So really and truly, you're just getting 4 times 3. The answer here is 12, and then 1 times 1 is 1. 12 over 1. The answer is 12. And yes, Zara, you are going to have to move back 2 spaces, but it might not be a bad thing. Oh no, it is a bad thing. I thought you was gonna land on the star, but you didn't. So Zara, that's where you reach. I think we have a good game going on there. Number 3, anybody?
So I
Yes.
get 1 over 4.
Right, 1 over 4, right? So check this out. Remember, multiplication glues things together, and multiplication is commutative. So you could write this in any order. Right? That means that this X could cancel with this X all the way over here. That means that this Y could cancel with this Y over here. That means that 2 into 2 is 1 could cancel with this 2 into 4 is 2 over here. That means that this 3 into 3 is 1. And let me just put my 1s where they're supposed to be. And then 3 into 6 is 2 over here. So now I have 1 times 1 times 1, which is 1. all over 1 times 2 times 2. 2 times 2 is 4. So 1 over 4. Was that your answer, right? Okay, well next up we're talking about dividing fractions now. And with dividing fractions, all we do is flip the divisor and then we multiply. So you notice I have A over B being divided by C over D. The one that is after the division sign is the divisor. If you want to write this as a fraction, you have A over B divided by C over D. It could look like this as well, but the divisor is the one underneath. Yeah, that is the divisor underneath there, the one after the division sign. The divisor, think about it like the terminator. The terminator is the one that does the terminating. The divisor is the one that does the dividing. But you flip the divisor. So instead of C over D, we now have D over C. When we flip the divisor, we multiply. And now you just multiply as normal. A times D is AD, B times C is BC, and all of that multiplication stuff we learned just now. Well, guess what? The Mario Maths. There we go.
First one you'll get 2 over 1, so I'll just be 2x.
Right, so that'll be x over 1 multiplied by, you flip this, so that'll be 2 over 1. And oh gosh, x times 2 is 2x is the answer for this one. Feel free to get it wrong.
X over 2.
Alright, so let's just see. We have x multiplied by, well remember this is 2 over 1. So we could flip this to get 1 over 2. Or we could just, you could just say x divided by 2 is x over 2. But I just kind of wanted to show you the method of how it all comes together. Right? Because of course you could have just go from here straight to here, yes. But it's important to see. It's important to see all of these things. Number 3.
So that's gonna be
Oh, that's I told you. Oh no, and Zara. All right, yes, Zara is Bowser. Yes. Anybody? Yes. For number. Divya. Yeah.
can I do it?
Yes, no problem. Now let Divya take it as here because Divya is normally a very delinquent person, so I'm very surprised that she actually participated here today. Yes, Divya. Let me hear you.
Let me do the math.
Yes, no problem. Yes, Divya.
So you flip the 6y over 2x and
So wait. You're right. So just now I'll have 3y over x multiply by 2x over 6y. Yes.
So the 3y cancels with the 6x and that gives you 2.
Right.
So
So wait. Don't rush. So y cancel with y. Right. And then I have the 3 cancel with the 6 to give me 2 here. Right. And then
on top is 2 by 1 and underneath is 2 by x, which is 2x over 2x.
well, we could also
So I
say
get 1 after.
right. So we could also say that this x cancels with this x. And then this 2 here will cancel with this 2 end. So everything just end up cancel off, literally everything. And the answer is 1. 1 times 1, 1 times 1. If anybody doesn't understand and want me to go it over, please say so. I say, oh, because you didn't get it over.
No, sir. I accidentally. I forgot to cancel the 2's.
Oh, yes. You had 2 as the answer. Let me see it. Alright, don't go too fast, over 2. Okay. And could anything cancel there? Alright, so what now? and that is pretty much the answer. And remember, even though this is the answer, we could also call this 1 over 6xy, yeah? And we could also write it as that. Yeah? So excellent job there, Asia. Asia, who do you want? That was dividing fractions. Anybody have any questions on that? Right, we're pretty much close to the end. Now we are talking about adding and subtracting fractions that have different denominators. We spoke about this already. In fact, everything that we spoke about today, we did at the beginning of June. Right, so this here should be a review, but now we get to see how all of this applies to algebra, because in the beginning of June, we were talking about arithmetic. And I was telling you one way to add and subtract fractions that will work for every fraction. And for example here, and I'll just put the example on the side here, right? If I have, say, 3 over 7 plus, let me just say 1 over 2, right? And I want to add these fractions. What can I do? Well, the first thing is multiply your denominators. 7 2s are 14. Then cross multiply. 3 times 2 is 6, plus 1 times 7 is 7. 6 and 7 is 13 over 14. That is your answer. That is it. That is it. When you're talking about adding or subtracting, this is all you have to do, and this will work for all fractions, right? So you multiply your denominators and then you cross multiply. Notice when I cross multiply the 3 with the 2, you know, wherever the numerator, that numerator 3 is, that is where I put in that answer. Right? I'll cross multiply the 1 with the 7, wherever that answer is, wherever that numerator is, I'll put in the 7 on that side. And whilst this is not important for addition, it is important for subtraction, because subtraction is not commutative. So, you know, 7 minus 6 is not the same as 6 minus 7. So be careful where you put the answer. When you cross multiply, put the answer wherever on the side of the numerator. Right? If you're confused about it, right? But this will work. So you can see here is the same thing. First, you multiply b times d gives you bd. Right? Then you cross multiply. A times d is ad, and then you have your plus or your minus, and then you have c times b is bc. This method will work for all fractions. Let me hear some dunnits, please. Any addition and subtraction that you have to do with fractions, just do this method. Multiply your denominators and then cross multiply, and you're good to go. Hopefully this should be an easy breezy for you. We do have some questions here, and this is actually the last of it, guys. This is actually the last of it. So you all think that we should do all, or which ones should we do, or would you like me to demonstrate one? Would you like me to demonstrate one? I'll include this one. So we're gonna do these 4 here. So we're not doing this and we're not doing this. We're doing these 4. So at least you'll have an addition, a subtraction, and then you have 2 containing funny business. For the sake of time, I will just do a couple. I'll just do it, and so that we can get out of here, right? So for this first one, I have 2 over x plus 1 over 4. Remember, it's just one method, I tell you, right? Multiply your denominators. X times 4,
4x.
right? 4x, and then cross multiply. 2 4s are 8. Plus 1 times x is x. That is the answer. It's as easy as that. This will work for all fractions, right? Then we do this one here. And 3 over x minus 2y over 7. Again, you multiply your denominators. 7 times x is 7x. Then you cross multiply. 7 3s are 21. And then you have this minus sign here. And then you have this here, which is 2y times x, which will give me 2xy. And of course, we have some tougher ones here. So we have this one, x minus 3 all over 3 plus 9 over y. Again, no matter how hard and stupid it looking, just multiply denominators. 3 times y is 3y. And multiply your numerators. Y times all of that is y times all of that. And then plus 9 times 3 is 27. If you reach here, you would have gotten it correct. Can we simplify it? Should we simplify it? What will happen if we try to simplify it? Yeah, if you got here, you'll get it correct. But for the sake of algebra, let's try to simplify this and see where we will reach, right? So x times y is xy. Right? I have the minus sign there, and I have y times 3 is 3y. And I have plus 27. All of this is over 3y. All of these are addition and subtractions over the same denominator. So I could split it up over the same denominator. xy over 3y minus 3y over 3y plus 27 over 3y. Alright, so it looked like simplifying it might help us out because these y's could cancel. So I'll have here x over 3 minus 1 plus 9 3s are 27, so 9 over y. Yeah, but when you really check it, what can I further cancel? The 3 with the 9?
Yeah.
No, you can't do that when you're adding and subtracting. And I'm happy that you made that mistake because it is a point that's important to me. You can't. Remember, the cross cancelling thing was for multiplication. So that's an excellent mistake to make, though. A lot of people would make that mistake. Don't make that mistake. But the thing is that when you look at this and you look at this, they're pretty much the same thing. It's the same thing. So really and truly, this is not simplifying at all. You just kind of got back to the original thing. So really and truly, this would have been your final answer. And let's go with this last one here. And I hope I'm not going too far. Alright, but we have this last one here. I'll do it down here. Negative 2 over z minus 1 over x. Now, remember how I was talking about, like, say, if you have negative 2 over z, which one is negative? Is it the 2 or is it the z? Well, the truth is anyone. You could take the 2 to be negative, or you could take the z to be negative. And to me, I would have always take the numerator to be negative. So now I don't have to worry about negatives in my denominators, right? So x times z is xz. Then I have negative 2 times x is negative 2x minus 1 times z is z. This is your final. Alright guys, I know all you want to go. I do have some stuff to show you though. So if we take a look in the Google Classroom here, this is fractions. So this is where I will post today's class. So today's class is the class on fractions. So today's class, the video will go here. The next class on Saturday, what we will be doing is we will spend that class doing fractions questions, because you know fractions is one of those topics that does require you know, some practice, right? So I have tons of fractions questions here. So this is one of them, expressed as a single fraction. It's just 4 questions here. It's quite easy. You can see we have an additions and we have a multiply and a divide as well. Right, so try that one out. Then we have this one. We have some random questions here, and all of these questions are pretty easy. Right? Some of these questions we actually, like this one we did today, this one we did today, so some of them we already did. Right? We have some here that involve BODMAS. So please be careful, because BODMAS applies to fractions too. So if you look at number 9, you have to do the multiplication first. BODMAS says so. Yeah. Also, if you look at number 10, think about things like the distributive law and think about things like factorizing, because those things might help you. But then, if you're good at fractions, we have our Spotlight Challenge. So the Spotlight Challenge here is for anybody who real good at fractions to see they want to tackle this, and the answer for this massive monstrosity is actually easier than you think. So I will see if anybody, this here is the Bowser. You can see Mario battling off against Bowser there. This is the Bowser. So let me see who could beat Bowser. So this fractions thing actually have 2 spotlight challenges there. This is 1 spotlight challenge. So this is 1 Bowser. Right? But if you look at this here, you will see that I have another spotlight 2. Another spotlight challenge. Let's see what this spotlight challenge looks like. So we have this spotlight challenge here as well. So we have 2 different spotlight challenges involving fractions, right? So these are the Bowsers, and then we have some random, no big amount of questions, small amount of questions we're gonna be dealing with here.